Welcome back to the QSUpali YouTube channel. I hope you have learned something from my previous videos. I wish to continue with this video to discuss the pricing of bill of quantities part 2. 1. External works continuation. 2. Day works. 3. Soil investigation. 1. External works continuation. Interlock pavers. In my previous video 21, I discussed laying interlock pavers on a prepared surface. Here I am prepared to discuss the cost involved with the surface preparation of level and compacted subbase for walking paths along driveways and parking areas. Interlock concrete pavers suitable for residential pavements and industrial hard stand pavements in the standard size of 200 mm in length by 100 mm in width by 60 mm in thickness. They are connected by a mixture of pavers, bedding sand, edge resistant and joint sand. The edge resistant includes a hard edge such as curbstones or any vinyl molded restraints or concrete restraints. Their interlocking feature enables them to be easily installed on the floor without the use of mortar bonds. There are varying thicknesses for interlock pavers, and depending on the location, the correct thickness must be adhered to ensure the paved surfaces prolong durability. For instance, 60 mm thickness of interlock pavers is substantially enough for areas of standard walking paths with aesthetic appeal to driveways, patios and gardens. Before laying interlock pavers, it is important to make a well-compacted stable subbase. This subbase is to be with suitable depth, filled with selected granular material and compacted to the required level. Generally, the minimum depth of the subbase for pedestrian traffic is to be 200 mm thick average. The subbase is to be compacted using a vibrating plate compactor, and the base must be well compacted and well to provide a smooth, even surface on which to lay the bedding sand. To secure pavers in place, 50 mm thick wash sand bed is required. Place pavers flat on the sand bed. Spread dry sand 10 mm thick average over the surface of the paved area, and using a vibrator plate compactor, pass over the sanded pavers to fill the voids between the pavers and sweep the remaining sand into void until they are filled. One number mason and one number unskilled laborer complete 70 meter squares per day. Breakdown items of interlock paver work for pricing. 1. Earthworks. 2. Subbase and compaction. 3. 50 mm sand layer. 4. Interlock pavers. 5. Filling voids. 6. Labor for laying. Example: the cost of supplying and fixing 1 meter square of 200 mm by 100 mm by 60 mm thick interlock concrete pavers with 50 mm thick sand bedding and 200 mm thick compacted subbase. 1. The cost of earthwork for 1 square meter equals the cost of 1 cubic meter of excavation and removal of thick topsoil from the site into 0.15 meter cube. The cost of preparation of subbase per 1 meter square equals the cost of 1 cubic meter of excavation and removal of existing subbase material into 0.20 meter cube plus cost of filling 1 meter cube of granular material into 0.20 meter cube plus the cost of high charge for vibrating plate compactor 1 cubic meter cube into 0.20 meter cube plus operator cost of compacting into 0.20 meter cube. 3. The cost of 50 mm thick sand bed per 1 meter square equals the cost of 1 meter cube of wash sand into 0.05 meter cube. 4. The cost of interlock pavers per 1 meter square. 5. The cost of filling voids of joints per meter square equals the cost of 1 meter cube of wash sand into spread wash sand 0.01 meter cube plus the cost of higher charge for vibrating plate compactor 1 cubic meter into 0.01 meter cube. 6. The cost of labor for laying interlock pavers per 1 meter square equals the cost of 1 number mason and 1 number unskilled laborer per day divided by 70 meter square. Therefore, the cost of supplying and laying 200 mm by 100 mm by 60 mm thick interlock paving tile per 1 meter square equals the cost of removal of topsoil plus the cost of preparation of subbase plus the cost of 50 mm thick sand bed plus the cost of interlock pavers plus the cost of filling voids of joints plus the cost of labor. 2. Day works. Day work is when a contractor is paid for the cost of labor, material and plant plus a markup for overhead and profits. Day works are generally used when an item is specially instructed to be carried out and is not measured or described in the contract document and cannot be valued with the rates described in the contract document. The contractor shall furnish hourly rates for his labor, material and plant in the tender document under the day work schedule. Based on these hourly rates of labor, material and plant, the contractor submits daily basis rates for a specified work. The contractor shall be solely responsible and assume liabilities for all consequences of operations on a day-to-day basis. The basic principle of day work is the work done is recorded on a day work sheet together with the labor, material and plant resources utilized to carry out the work. Most standard forms of contract make provisions for variations to be valued daily. The time spent should be as accurate as possible and should be authorized by someone in a position to verify that the resources identified on the sheet have been used to carry out the work described. The person signing the sheet may add the words for the record purpose only. This is exactly what the day work sheet is, a contemporaneous record of the facts. The act of signing the day work sheet does not ordinarily create an entitlement to payment or intention to make payment. Ordinarily, the rates used to price the day works shall be prime cost rates to which an agreed overhead and profit percentage is added. Therefore, the prime cost should be agreed upon by both parties in advance. 3. Soil investigation. The purpose of investigation is to provide a report for data on the soil of the site and its characteristics and conditions. The report fulfills the objectives of the safe and economical depth of the foundation and forms the basis for any potential instabilities and minimize settlement of any such outcomes during the life of the structure. This includes field investigation and testing as well as laboratory test results and recommendations. The report may also include details of the proposed structure, site conditions and history of the land used, detail of adjacent structures, number of boreholes used, condition of substrata, water table, field testing and sampling, and laboratory test results. Thank you. Please wait for my next video for the continuation of the discussion on the direct cost analysis and other schedules and more on the other upcoming videos. I will be pleased if you are motivated by the desire to explore the value of the fields necessity that would contribute to the construction industry. Please refer to the description box below for the written description of this video clip. With a positive attitude and a growth mindset, keep moving forward and explore the field. I will see you in the next video. If you are inspired and learned something in this video, please click like, subscribe to my YouTube channel and press the bell button to receive my upcoming videos and share with others too.